Today's lesson is on factoring trinomials of the form x squared plus bx plus c. So note here that there's no value in front of x squared other than the 1 for everything we're going to do in this lesson. First, let's just do a quick review of some distributing. We used the FOIL technique to do this earlier. If you want to practice yourself, just stop the video, try them, and then check the answers. All right, check your answers to make sure you've done these correctly. I also simplified each one of these examples. In the first one, I got x squared plus 2x plus 3x plus 6, but then you can see these two terms in the middle combined together to be 5. In the next one, I got x squared plus 9x minus 4x minus 36. And once again, we had some simplification. The middle two terms combined together, since they're alike, to be 5x. Our entire lesson today is going to be about factoring and really reversing this process. We want to be able to go from the answer all the way back to the original. To do this, we're going to use some things we know about the actual distributing process. So let's take a look at some of these numbers that you see in the answer itself. Namely, this last number here and the number in the middle. There's a definite connection between the values that exist inside the parentheses based on the numbers you get here. The big thing is these two numbers that we're looking for, like in this case, the 3 and the 2, multiply together to give that 6. Those same two numbers add together to give the 5. So this number is multiplication, and this number in the middle is addition. Same thing happened down here with the 9 and the negative 4. They multiplied together to give me negative 36, but added together to give the 5. This is the pattern we want to use when going in reverse. Let's look at some examples and practice this skill. I know both of these are going to be two binomials, and they're going to start with x's. Because everything's positive, they both will have positive signs as well. What I'm trying to do is make either a mental list or an actual list to the side of values of 12, numbers that multiply together to give me 12, and add up to be that 7. Like 12 and 1, 4 and 3, 6 and 2. These are all potential values. However, the only one that adds up to 7 is the 4 and 3. That means those are factored values, 4 and 3. You can have them in any order, doesn't matter. 3 could be first and then the 4, still the same answer. Let's try some more. In this one, I want the two numbers to multiply together to give me 24, but add up to be negative 11. We could have 24 and 1, 12 and 2, 6 and 4, 8 and 3. But you notice all of these that I've just given have multiplied together to give me positive 24, but are adding up to some positive number. I want it to add up to a negative number, so I'm going to do one switch. I'm going to make all of these negative. It's the only way we can add together to get a negative number, but multiply to get a positive. I'm going to select this last one. It's the only one that adds up to be negative 11. So I'll have x minus 8, x minus 3. In the next one, I want to multiply together to give me a negative 10, but add up to be a positive 3. So I'll start making a list. Since I have to multiply to get a negative number, I'm going to have one positive and one negative. So there's going to be a lot more options here, like negative 10 and 1, or 10 and negative 1. These are different. Negative 5 and 2, 5 and negative 2. I think that's it. I want to choose the one that gives me positive 3, so there it is. positive 5, negative 2. The factors look like this, plus 5, minus 2. If you're good at multiplication facts, this is something you're probably just going to do in your head without any work to show at all. If you're not, then consider making these lists like I did on the side. Just list out all the factors you can possibly think of, and then it becomes like a multiple choice question for yourself. Try these 3 yourself, just to see if you're following along. Okay, check your work. I went ahead and listed the factors out just so you can see my thought process along the way. The last one was the most challenging just because it had the most factors. There's actually more factors than this, I believe. But as soon as I found it here, this 7 and negative 8, I stopped. I just didn't need to do any extra work. There's only one right answer. Okay, so check over that to see if you did those correctly. Let's look at the next one together. I'm trying to think of numbers that multiply together to give me 12, but add up to be 10. So I have 12 and 1, 4 and 3, 6 and 2, and that's it. None of those work. This is not possible to factor. If you think about it, just numbers, regular numbers that don't have factors, we call prime, so we call this prime as well. Just like a prime number, it has no factors. Just doesn't work. Next thing we want to do is actually look and see how we're going to use this to solve equations. If you remember back to our previous lesson, we talked about something called the zero product property. If you have something equal to 0, specifically a product equal to 0, one of those factors must equal 0. There's no other way it can happen. So if I can get this in a factored form, I can set those factors equal to 0 and solve. This first one, I'm looking for two numbers that multiply together to give me 15, but add up to be 8. Do you have the numbers? 3 and 5. According to the zero product property, one of them has to be 0, either the x plus 3 or the x plus 5. I'm going to solve each of these little equations to get the solutions. Negative 3 and negative 5. Either number will work. In the next one, I'm trying to think of two numbers that multiply together to give me negative 6, but add up to be positive 5. Think about those factors. Should be plus 6 minus 1. Set each factor equal to 0. And then solve each individual one. Two solutions will work. The answer is either going to be negative 6 or positive 1. Here's another one that's just slightly different. There's no 0 there. The zero product property only works if you have a 0. So I'm going to modify this before we even get started. I'm going to go ahead and move the 45 over to the left. And now it's just like the problems we did before. Okay, so that 0 is going to be necessary. Here I need two numbers that multiply together to give me negative 45 and add up to be negative 4. This will be negative 9 and positive 5. It was a little bit more challenging. I had to stop and think a while. If you need to, remember just to make a list on the side of your paper of all the different possibilities. All right, each one of these factors, I made a X there, should be a Y. each one of these factors could potentially equal 0. Either the y minus 9 equals 0, or the y plus 5 equals 0. When I solve it then, I get two solutions, 9 or negative 5. Either one will work. This last problem is a word problem. We have to find two consecutive integers whose product is 72. I don't know either one of them, so let me go ahead and make some variables. First thing is, I'm going to make x be the first integer. So I'll say that's one of the integers. Since they're consecutive, the next one should be just right after that x. Instead of calling it y as another unknown, I'm going to make the next one be x plus 1. According to this, their product, or when we multiply them, we should get 72 as an answer. So when I take x times x plus 1, I get 72 as a result. I can solve that using the same techniques we had before. It just takes a little bit of work to get it set up. I'm going to have to distribute to find out exactly what this trinomial looks like. That's x squared plus x equals 72. Just like the previous example, I'll need to move the 72 over to the left to get a 0 on one side to make the zero product property work. Here I'm looking for two numbers that multiply together to get negative 72 and add up to be 1. Or positive 9, negative 8. By setting each one of these factors equal to 0, the x plus 9 and the x minus 8, I get two solutions. Either x is negative 9 or x is positive 8. Two different sets of numbers that work. Now to actually answer the question, I need to give the solution. What are those two consecutive integers? Well, one of them would be negative 9, with negative 8 being its next consecutive integer. The other one would be the positive number 8 and its next consecutive number, the number 9. Either set of numbers will work and will count as two consecutive integers whose product is 72. So we need both results.